In this project, our driving question was, what can we learn about environmental gases and open source hardware from sending a helium balloon into the upper stratosphere? In the Pie in the Sky seminar, we worked on labs that would improve our understanding of the various gas laws that would interact with the balloon and the sensors. These included studying the ideal gas law, in addition to learning about the layers of our atmosphere. Each group of students was assigned to master a certain part of the technology that would be in the payload. The first item that we put in our payload box was a Vernier LabQuest 2. We also packed in a temperature probe, UVB light sensor, and barometer, an Arduino microcontroller with a Vernier probe shield. Using code by Vernier that we modified, we attached a magnetic field sensor to record data each minute during the flight to EEPROM memory on the Arduino. Next, we added a GoPro camera to record a video of space while the balloon was up in the atmosphere. A spot tracker GPS was involved to tell us where the balloon was when it landed. We put a marshmallow on a spike off of the box, then we watched with a camera hooked to a Raspberry Pi microcomputer. A Raspberry Pi is an open source microcomputer that we programmed to take pictures every minute for 4 hours on device startup. The box was painted with a pig motif so that we could identify it upon landing. The parachute was attached so that when the balloon burst, the box would slowly descend to the earth instead of a simple speedy drop. We utilized a program from habhub.org that would take into account the jet stream, the ascent and descent rate, the time of day of the launch, burst altitude, and location to get an estimate of where the balloon would fly, pop, and land. We tried our best to have it land in a field. We saw that if we drove out to North Branch, Minnesota, we could get it to land just southwest of Rice Lake. We split jobs between the students to aid in filling and launching the balloon. We filled the 1,500 gram balloon with 1,400 psi of helium gas, which is equivalent to 155 cubic feet of helium.
I've always wanted to see pigs fly.
All right. 10, 9, 8. Help me, guys.
7,
6, 5, 4, 3, 2, 1. Let her go. There he goes.
We determined the max altitude for launch using initial GPS altitude. Our altitude measuring equipment only measured at 12,000 meters, so we had to drive an average ascent rate using our initial data. We graphed time in seconds versus altitude for the first 12,000 meters of our launch, finding this to be a linear relationship with a slope of 5.42 meters a second. With that information, we could calculate how high the balloon went, since the exact time the balloon popped was recorded by our onboard GoPro camera. We know that from the time the balloon was launched to the time it popped was 94 minutes, so we converted minutes to seconds and took 5.42 multiplied by the total time in seconds. We found the balloon went roughly as high as 31,000 meters.
Our graph shows that as the balloon rises, the temperature gets colder until around 20,000 meters. This, we learned, is the same area where the troposphere ends and the stratosphere begins. As the balloon reached the stratosphere, the temperature began to rise. Most sites say that in space the temperature will be cold, then will get warmer in the stratosphere because of the ozone layer. In the ozone, it takes air molecules and turns them into heat, which makes it hotter.